Problem number 802. Find eventual save states. There is a directed graph of n nodes, with each node labeled from 0 to n-1. The graph is represented by a 0 index to the integer array graph, where graph I is an integer array of nodes adjacent to node I. Meaning, graph I is an integer array of nodes adjacent to node I, meaning there is an edge from node I to each node in graph I. A node is a terminal node if there are no outgoing edges. A node is a saved node if every possible path starting from that node leads to a terminal node, or another saved node. Return an array containing all the saved nodes of the graph. The answer should be sorted in ascending order. Okay, so a node is a saved node, no outgoing edges, terminal node. So like this two, like 5, 6 will be terminal node. And okay, a node is a saved node if every possible path starting from that node leads to a terminal node. Okay, so 0 will go to 1, 2. We'll go to 5. And okay, so yeah, you should be directly pointing to connected to the terminal node. So the first thought that I came up will be, yeah, like first for loop, yeah, first find terminal node. Like for loop, graph, and select the empty arrays. Yeah, so we will find 5 and 6, and then we will check every node, check the connection of every node. Check the connection of every node. And see if the path contains only terminal nodes. So it will be like it's a directed graph, so Okay, so we cannot yeah, I'm thinking if because for this we will have to make for loop graph and for loop each connection. So it will be like an n plus e. Yeah, e is the edge of count. So it will be like n plus e. And for the order, ascending, the answer should be ascending order. Yeah, since we are having a for loop, I don't think that's a problem. Okay, so we will find the terminal nodes. So I'll have terminals, it's a set, and we'll for loop graph, for loop, and node, and connections in array. So if and then we will for loop connection. So C in connections. If C in set, C in terminals. Okay, if C not in terminal, then we will break. Yeah, let's see. Yeah, we should okay, we'll have save nodes. Saves. It will be an array. So if C okay, I think we should have like a tag to we'll have terminals equals true equals false. If there is no connection, yeah, so we'll have true. If there is no connection, if all terminals, then saves append node. If C not it in terminal, we will break and we will have change terminals to false. return saves. Okay, that's dry run. So yeah, for graph, first of all, it will be 0, 1, 2. Notice 0, 1, 2. Oh, we haven't formed the terminal. It's okay. So for now in connections in graph, if connections, okay, if not connection, it's empty, then we need enumerate. Let's have nodes. Yeah, we'll have terminals, add node. Okay, so for first of all, we will have enumerate the graph. We will have 0, 1, 2. It's not. 1, 2, 3. It's not. 3, 5. Sorry. 2 and array of 5. It's not empty. We will have 5, 6. Okay. And okay, so yeah, this will have and for this we will enumerate the graph again, and then yeah, so for it is 0 node, connection is 1, 2. So C is 1 at first. C is not in the terminal. All terminals will be false and break. Yeah, we will not do 2. Then all terminals is false, so we will not append. And then we will move on to node 1 with 2, 3. But 2, 3 is not in the terminal. Yeah, 2 is not in terminal, so break. And then okay, so move on to node 2 connection 5. C is 5 is in terminal. Okay, so it's not, yeah, so we will have all terminal, then we have finished this connection for loop, so we'll have all terminals equal to true. We will append 2. Okay, then we will have 3 with node 3 with connection 0, and C will be 0. C is not in terminal, so we will have all terminals equals false, then append. Yeah, we will not append. Then we will move on to 4, node 4 connection 5. C will be 5, and 5 is in the terminal, so we'll have all terminals equal to true, and we will have append. Yeah, append. Yeah, this we will have already append 2 and 4, and then it's now 5. for 5, connection is empty, and we will not move into this connection, so we will have all terminals true. We'll append 5 and 6 as well, and then we will return. Yeah, I think this will be correct. Oh, terminals. Oh, this is 0 and 4 is in the terminal. Oh, it says, okay, so like if a node is pointing to, like this node 2 is pointing to terminal node, it's a safe node, and yeah, it is also pointing, yeah, like 2, it is also pointing to a safe node, which is 3, and okay. Okay, so it's not that easy. We will have I think, yeah, we should do a DFS and maybe make the saves to a set so that only saves can be added. Yeah, like so yeah, we will have a DFS. I'm thinking if we can have a, yeah, I'm not sure if we need a visited set to or maybe we can have like yeah, like a status array, and that will be 0 at first and then multiplied by n, so we'll have n equal to length graph. We'll have n, and yeah, we will have, if status I is 0, then haven't visited yet, and if status is I will say if it is Yeah, if it is 1, then it's a safe node. If it is 2, it's a terminal node. And if not, then we will have 3, like not safe and not terminal. Okay, let's see. So if a node is a safe node, if every possible starting from, yeah. Guys, and the status will not change since only will change from 0 to 1 to 3. It will not change from 1 to 2 or 2 to 3 or 1 to 3. Since if you are a safe node, yeah, then you will always be a safe node. Every path will be either to terminal node or a safe node. Okay, so we will have, I think status, like we'll have it first, and then for the first connections, we don't need the terminals. We will have equals 2. And we will start, so for loop the node in graph I. Okay, if status node equals to 0, yeah, let me think, like, yeah, if you have a node that is not visited yet, we can visit. Yeah, we should be like, okay, like 2. 0 is a, okay, if status node equals to then we can continue. Yeah, nothing happens. Okay, if it is 3, then we have to, yeah, we have to tag this node to to 3. And others if, and we can return. status node is 0, we can do dfs dfs node. Oh, we need its status. Yeah, if it's a safe node, maybe, okay, so we can return 3. And for this, let's return dfs node. If we finish, okay, I'll say status. Oh no, they have stat equals -1. So if stat will be equal to 3, and stat will be equal to dfs node, and stat will be for 3 we can already return like and yeah, if you finish the for loop, then we can return. That means you are not 3 and you don't have 0. Status I will be equal to dfs node. Return status I. Return 1. If status I equals 2, then return 2. Else return 1. And for for node in range n, if status I equals 0, then we will run dfs. And then we will pick, we will return for loop status in status if that equals if that is between 1 and 2. I think this return thing and status thing will have something incorrect. So I will check so for set I, so the first thing we will have, let's take this case for example. So we will have 0, 0, 0, 5 zeros, and then we will have this as 2, and then if status I equals 0, then we will start. So, it's I. So we'll start from I equals 1, status 1 is 0, dfs 1. For 1, we'll have 0, 2, 3, 4. So for 0, it is 2, so we will continue, and then for 2, it will run into this condition. So I think this will be status I equals dfsi. Okay, so so 2, now node is 2, it's 0, then we will have dfs 2. For dfs 2, it has 3, so node is 3 now. For 3, is 0 as well, so we will dive into. So status 3, I is 2, but node is 3, So node for node 3, dfs 3, I is 3 now. Node is 4. Since node 4 is 2. So we will not go into any of the condition. Then node then we finish this graph. Then we finish this for loop. Yeah, we cannot write this like okay, sorry. So I is now 3, but node is 4. Finish. So I is 3. 3 is now still 0. So we will give it 1. So yeah, so now DFS node 3, it's 1. Okay. And yeah, we will run into this, and then 3 is 1. Okay, node 3 is status I will be okay, it's kind of so we will have I equal to 2, and we have I equal to 1, and node is 2. Okay, so we will be here, and it's okay, we'll have DFS 2. We'll have status I, status 1 equals to DFS 2. But 2, okay, 2, then we have 2, then node is 3. So actually it is DFS 3. 3, we have 4, DFS 4. I think we can return 1. So it will all be 1. But I'm not sure if we have marked for DFS 4, yeah, node is 4. 3 is I, status 3 is DFS 4, and for DFS 4 it should return to. Or maybe if status node yes, dfs 4 is 2, but dfs 3 should be 1. I think it will be easier if we only have 3 states, like terminal node is also 1. So it should be 1. I think I have to have the state here so that, yeah. I think using a return is not a good idea. Like, yeah, it would be better if we use like a state would be zero. Yes, and this will be the state, and we will for loop the connected nodes. If status node is 2, then we will have state equals 2. We can break. If status node equals 0, then we will go deep. We will have state equals to it. yeah, this may be yeah, but like this one, yeah, for this example, if you got 0, for at 0, you can navigate to 1, can navigate to 2, 2 can navigate to 5, and 5 is a 5 is a terminal node, so 2 is a safe node because it only leads to the terminal node. Oh, so 2 is a safe node, and we can check 0. The 0 is a safe node. 0 will navigate to 2, it navigates to the safe node, but 0 will also navigate to 1. 1 is a safe node. No, because 1 navigates to 2 is a safe node, but 1 navigates to 3, 3 navigates back to 0. Is this also a problem asking for cycle? Yeah, the thing is, I'm not sure if the only thing that cannot put in the out answer will be having cycles. And if having cycle, like if we are now 0, so state will be 0, and we have 1, node 1. Node 1 is 0 as well, so we will go deep with node 1. And node 1 will have 2. 2 is a safe node, but we will not run. Yeah. Then we will see 3. 3 is 0, so we will dive deep. And 3 will navigate to 0. We will have a cycle and have an infinite loop. So I think we have to we need like a visiting. So visiting, we will change it to 1. So when one, and if you meet, okay, if node okay, safe node and terminal node will be 2. Not safe, not terminal will be 3. If you made, yeah, then you will be 3. And if this node is 0, you will run into the DFS. And okay, so 3. Okay, if you meet 1, then if you meet 1, state will be 3. You can break, I think, or if 0, then you can have DFS. And after all the I think you can like this, and you can return. Yeah, and if you finish all this for loop, and you can get 2. I don't need this. Yeah, okay, so maybe let's try run. We can try run the example 1, so we will have 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. Have 7 zeros. Okay, so yeah, we'll first have terminal nodes. I don't think we need this, maybe. Yeah, because okay, maybe let's see if we don't have this first. Then for I in range n, yeah, graph. The first node 0. Oh, then we don't need. Okay, yeah, like 0. Okay, 0 for 0. Example 1. We'll have DFS 0. Status is 1. Okay, let's change it to 1. And then for node in graph I, That's 1 and 2. So for 1 first, 1 it's not 3, it's still 0. It's not 1. Okay, so we'll have status 0 equals 0, then we'll dive into it. So we'll have node 1 dfs 1, and for dfs 1 we'll have node 2, and node 2 has node 2 is status 0, so we'll dive into node 2, and for 5 it will become, because it doesn't run the graph, so it will have status I equals 2. So 5 we'll have 2 here, and then yeah, that's return. So we'll back to this yeah, we'll here I is 2 now. So I is 2, node 5, yeah, we are here. Node 5 is 2. Then for 2, it's 2 as well, since it already finished its for loop. Okay, and then so for 2 we are here, node 2, and then we will have node 3. Node 3 in graph is 0. Oh, sorry. Yeah, we have node equals 3, and status 3 is 0 now. So we will dive into node 3. Node 3 is node 0. Oh, yeah, I forgot to change these into sorry, so yeah, it's a bit long, so it's we have, okay, we can start over again, like it's I is 0, we have 1, and then we will start our node 1. So node 1 it's 0 first, and we will dive in. So for dfs 1 we will be update to 1, and for node 1 we have 2, node 2 is 0, so we will first have 1, and then we'll have 2. Yeah, and it will go to 5. Yeah, 5 here, so it will go to 5 will be 1 first, and then it will become 2, since yeah, 5 has an empty array, and then the 2, when I is 2, node 5 is the only node in the graph I, in the graph 2, so it will finish and it will get 2 in the status. So now we will turn into 3, node 3, and node 3 is status 0, so we will have dfs 3, and we will have here 1, and then for node 3, node is 0, oh, we met 0 equals 1, so we will have 3 becomes, yeah, I is 3 now. 3. Okay, then I3, so then because so return, and we finish this. This has finished the for loop, and then we'll back to here. Oh, we did not, like, if any of it has 3, then we should mark it as 3. Maybe we have this, and then you should okay, so maybe you'll have this, and if set equals 3, then 3, else it will be 2. And return. Return status I. Okay. Okay, let's have that equals 1. Oh, you should enumerate. And this is I. And you have to return I. Okay. Okay, I think I found the mistakes lies here, like this statement, because if a connection some are return 3, some are return 2, then yeah, it will be, yeah, this st will be override to the last node, so it will not be correct. So I think I should have like a global, yeah, like let's say is okay, invalid. We'll have okay, I'll have it here. No st anymore. We'll have invalid equals false by default. If invalid, then we'll have 3, else 2, and then we'll return and invalid will be true. I'll have break. Yeah, return because I already set. Or we can have break and we will all set here. Wait, like yeah, I don't know the child. Return. Okay, we have invalid equals. No, we must have yeah, I think invalid should be maybe this. Oh. Oh. It should return false. I think we should return invalid.